All right, so wooden wind chimes. So here's a pretty decent attempt at wooden wind chimes. I've always liked wind chimes, especially the bamboo ones, and you only really ever see them as bamboo wind chimes. So I thought, let's give it a try and see what happens. So just to go over the terminology so we're all on the same page. So the ring that holds the whole thing, the cap, the chime tubes, the bell, and the sail. Okay? Now obviously this particular design is the most simple, most common style of wind chime. You see them everywhere, home stores and things like that. But it's kind of a good representation, and the skills that you'll get will help you do any other wind chime. With all the demos that I do for you guys, I like to kind of do something that will maybe inspire you, and you certainly don't have to make anything like this. Wind chimes, if the wind is pushing one piece of wood into another piece of wood and it makes noise, that's a wind chime. Okay, so what do we need in order to do wooden wind chimes? You need some wood. Preferably you want dried lumber, straight grain. You don't want a lot of figure in your grain for the tubes themselves, because it's all about the musical note. If you have a lot of figure in your grain, it's going to change the resonance of the piece of wood. So these are pieces of mahogany, spindle blanks. So we need to start by finding the center on each end. So you can either use a center finder or the old-fashioned method, corner to corner with a straight edge. It is important that when you make your spindle blanks, that you make them square. You don't want this to be rectangle. These are, I think, 1.5 inches. 1 3/4 by 1 3/4. Because when you chuck these up, if it's a rectangle, it's not going to sit right in the lathe. And for this particular operation, it's all about keeping this piece of wood parallel to the bedways. Okay? Once you got the centers, your drill or your live center, to put a nice little dimple in there. And obviously today I'm just going to do one of these. It does take a bit of time to do 6 or 5 or whatever. So we're just going to do one. So first thing we're going to do is we're going to put it in our chuck loosely. And you're going to mount it so that the corners are between the jaws. You see that? Okay. So that the jaws themselves are gripping on the flat facets of the piece of wood. And I've got this in here loose, just enough to kind of hold the piece of wood. We're going to be drilling this with brad point drill bits as opposed to Forstner bits. So the reason we do a brad point drill bit, number one, it's longer. I feel it's more efficient at drilling the end grain wood. Plus, it's a brad point. So it has this little point on here that we're going to use as a dead center, essentially. So this is how we're going to drill it. No support on this end. The drill itself is going to be the support. And that is the big secret. So we've got this loose. We're going to bring up our tailstock and put it right in that dimple. Then we go back to the chuck. Now we can snug this up. Now I know that this piece of wood is as perfectly parallel to the bed as we can get. That will ensure that we drill a nice straight hole all the way through the center. Everybody follow me so far? This is a 1-inch bit. So I'm basically going to do this exact same thing. 1-inch hole through the center, and the tubes themselves are 1 1/4 OD. Safety glasses. Now when you're drilling, you want to let the drill bit do the work. Especially doing something like this. We want a nice straight hole. I could crank this in here, full bore, but that's going to cause the drill bit to start to wind off center, and then we get that wobbling thing. I'll usually go 1.5 to 2 inches. If you have a compressor with an air gun, works really well to clear the chips out. And I'm watching the chips fall. As soon as I see that the chips are not really coming out on their own, then I'll pull the drill out and kind of clear everything out. Now the reason I don't like using the Forstner bits on these is because I feel the Forstner bits require a lot more pressure to actually drill. The flatness of the Forstner bit hogging away at, 1/2 inch and 1/2 inch of material definitely is going to want to make it wind off center. That's why I feel the Brad Point bit is just a stronger bit for this application. Plus that long point at the tip helps keep it going straight. You also want to make sure that when you do that move and you slide it in to get deeper, don't slam it in, because it will push everything off center. You might want to turn your hearing aids off. Okay, so we're about as deep as I'm comfortable going with just the standard bit. So now we will switch to our extension. So what I'm trying to do is I want to hit about 2/3 of the way through, and then we'll flip the piece of wood around and finish off the hole this same way, and the 2 holes will meet in the middle. Hopefully we've got enough length here. I have a robust lathe at home, so I can just swing the tailstock out of the way. We're going to... Now I need to be especially careful, since I can't really get the drill bit out, to make sure that I don't bind it up with all the chips. See, we got a little wobble going on. When you're practicing this demo in your head, you can think of every possible problem except the one that's actually going to happen. Not real fast. Yeah, we should be good there. Okay. Now, same procedures. We're going to turn it around and do the same thing from the other side. Grabbing it corner to corner loose. And then go back and retighten up the chuck. Don't crush it too much because you know it's hollow down there, so... Oh, maybe I didn't go deep enough. Should be pretty close. There we go. Just enough. Okay. All right, now the noise is done. Okay, so the drill hole is complete. Now we can take and set this up and actually start doing some turning. So we're going to take our drill chuck out. We're going to turn this between centers. So in order to do that, we need some sort of a drive cone on the headstock end. So I've pre-made a drive cone, and I use these all the time when I do my hollow forms for flipping stuff around so I can turn. Come in really handy. Quick tip for you: when you're making a fixture, or even when you're doing your bowls, if you mark your number one jaw and you can kind of get those teeth back, you should be able to put it in and it runs totally true again. Then for our tailstock, we need our cone center on there as well. Now, assuming you're doing wind chimes, you're going to be doing kind of a production turning kind of deal. So you want to set up your lathe to be able to do multiple pieces, and you don't want to keep shifting your tool rest around end to end. You want to make it so that you can just move the piece of wood around and just keep turning. So we're going to get this all set up nice and parallel, set at the right height, and nothing hits. So what we're going to do is we're going to turn one end. You'll see that in this process there's a lot of repeating. So the drilling, we drill one way, flip it around, drill the other way. Turning the same way. We're going to turn, we're going to get this to size, we're going to flip it around, then we're going to turn the other end. And this is throughout the whole project. You're going to see a lot of this repeating process. Spindle roughing gouge, normal spindle turning procedures. We're going to knock down the corners and get it to a round cylinder. Following the ABCs of wood turning: anchor, bevel, cut. Once you find that correct angle, you just keep following it down. Okay, and notice that when I'm turning, roughing this out, I'm keeping my body stiff or robotic, and I'm just sliding back and forth, keeping as one fluid cutting tool. Okay? All right, once I've got that rounded to a cylinder, then I can switch to a parting tool and a set of calipers. I want to have an 1/8 inch wall thickness, approximately. So 1 inch hole plus an 1/8 inch plus an 1/8 inch gives us 1 1/4 inch. So I need 1 1/4 inch finished outside dimension. And again, normal spindle procedures. We're going to give ourselves some reference marks. Start right here on the end. Come close to this end. And then somewhere about in the middle. Now all we have to do is go back to our spindle roughing gouge and just connect the dots. Oh, so my bevel, I believe, is cut at a 40. As I'm coming into the edge, I'm turning slightly to come into this edge, and I'm stopping just shy. I don't want to hit any of this, because then you're going to get the inevitable catch. You can get a finer cut if you come in and make more of a shear roughing pass. But I think for this, because it's a straight cylinder, it's not really necessary. I will tell you, I am not a spindle turner. I can do it, but I like bowls and hollow forms and stuff like that. So I will get this close. The finish will be decent, but I'm going to show you how to do this and not be a spindle turner. So I'm good with that. You can see it's, well, fortunately our cameras aren't that good, but it's a pretty good finish. So we're going to turn this around, same exact thing to the other end.
Why do you turn it around?
So that I can leave my, because keep in mind, you're going to be making, multiples of these. So I don't want to keep moving everything around on the lathe. I'd rather just flip the piece of wood end for end. That's a lot quicker than readjusting the tool rest. I forgot to mention that when you're doing your spindle turning, always start in and work your way to the outside edge, at least until you get it round. Since I already have finish size here, it's going to go about here. So we're pretty good. We're a little low here in the middle. Let me touch that up a little. Okay, so back to the not being a spindle turner. So that honestly is probably, if I work on it a little bit more, I could probably get it better, but this is good enough for what we're trying to achieve for turning purposes. Now we move to the 60 grit tools. Okay. Now, I know we joke, 60 grit tools, This is invaluable. I truly believe sandpaper is one of the most important cutting tools in our arsenal. For this, making up for my deficiencies as a spindle turner is spectacular. And I do a lot of hollow forms that are these straight type cylinders, rolling pins, like this is a good technique. Sanding block and some rough sandpaper. This I think is actually 50 grit, so it's even better. The reason I like this, as wood turners, you know that you spend all this time to turn a bowl or a hollow form or something, and it's all nice and round, and then you start sanding it, and then it's not round anymore because the sandpaper takes away the hard and the soft woods differently, especially on bowls. On spindles, you have the same problem, not as bad, but even though this is straight grain, you do have some hard and soft areas. So if we sanded this normally, 150 grit and up, it's going to end up oval, somewhat oval. The really rough sandpaper takes away wood so quickly, and it doesn't care if it's hard or soft. It keeps it pretty round. Okay? This is really the only sanding that I'm going to do, so I am going to put on a dust mask. Now we'll switch to 100 grit, same exact thing. And this is really just to take out the really rough scratches from the 50 grit. There, and now it looks like I'm actually a spindle turner. Now we go to all the normal procedures. I'm going to go with 150. And always, when spindle turning, always sand with the grain when you're done. 18 1/4? No, but I do bet that the harder the woods, like say a hard maple, would sound even. The harder the wood, the higher the pitch. So I did the mahogany just because it's nice and soft and easy. And then finishing off with 400. Now last thing for sanding, how many people use Scotch-Brite? Just a couple. Scotch-Brite is awesome. Same thing we're doing. We're going to go a little faster though. And since I'm happy with the finish of the 400 grit, I'm going to skip right to the white Scotch-Brite. And this is basically just going to burnish the surface. Both directions. I use Scotch-Brite on all my finishing, and I use pieces like this. This is a brand new one I cut for demonstration purposes, but the one that I use at home I've probably been using for 2 years. So it really lasts a long time. When I'm happy with the finish like this, white is really all I feel I need. White is the highest that you can usually get like in regular hardware stores and that. Woodcraft sells a kit. It's 2 sheets of each. It's the green, the maroon, the dark gray, and the white. So there is the finished turned tube. We'll do one more thing to it and then call that one finished. So the inside is a little rough from the drilling, obviously. We just want to pretty that up a little bit. So I've got a coarse grit flap sanding drum that I made. As wood turners, it's pretty cool that we can make everything that we need. So I'm thinking about it, and the question about if you go with a harder piece of wood, will it make a different sound? Yes, it definitely will. I do think that the drilling procedure, you're going to need some serious hearing protection for that. So, all right, so we are done with this. It is worth noting that you could skip the first 2 rough sanding stages on that if you just become a better spindle turner. But let's be honest, spindle turning, what are you going to do with that? Make a 3-legged stool? I mean, what kind of fun is that? That drill bit from Rockler, the 1-inch was, I think, $15. Christmas time they had a sale, so I bought 1-inch and down. And I think all said and done, I think I spent $40, and I'm all the way down to 1/4 inch now. So good deal. And I think they're still on sale at Rockler. So we're going to work on the cap now. This is just an old piece of walnut that I have. We're going to do this between centers, but we're going to do it a little bit differently. I don't want to use a drive spur because I don't want to tear up the wood. That just makes more work. So I've already found center, and I put a little center dimple in there. So we're going to put it right against the face of the spindle. And the nice thing is, the face of the spindle is perfectly square. So by doing this, I've squared up my piece of wood. And I need a little hole there anyways for this center string. So the tailstock's kind of getting that started for me. Nice thing about wind chimes is there's really no standards. I mean, this is a common design, but you can make different lengths. So, and I'll talk about this when I talk about tuning the chime tubes, but there is tons of information online of different types of tubing and what lengths to cut to get different musical notes. That's a whole nother world. So we're just doing the basics here. Anchor bevel cut. That's better. All right, so we're round. I'm just going to give this a little curve, pretty it up a little bit. I'm really only standing this because I don't want you guys to judge me. Okay, good enough. You guys get the idea. So while we have it set up here in the lathe, we might as well do some layout lines for where we need to drill some holes. Again, there's not a lot of rules in making wind chimes, but there's some general things. So think of the top cap as kind of like the roof on your house. You want everything else kind of underneath it. Again, if your artistic vision is different, do whatever you want. But for a general design, we're going to do that. So our chime tubes are 1¼ inch. So half of that is 5/8. So we need to be in at least 5/8 of an inch. I'm going to go a little bit more and go 3/4. Okay. And then that gives me a reference as to where I'm going to drill all of these holes to hang the tubes from. Layout-wise, you can use your indexing head. You can go the old school geometry with a compass, or you can just eyeball it. We're going to do 5 tubes. So that is the cap, and then we would do all the drilling on that. Obviously, I would sand the heck out of it, but the bell is basically the exact same procedures, just smaller, and you don't need all the layout lines. I also don't like turning left-handed, but sometimes you have to. You definitely want to make your bell with a curved surface. You don't want it to be square because you want one point is actually contacting the chime tube. If you make it square, like a straight-sided disc, you're going to have a potential of corner to corner hitting the tubes, which will give a slightly different sound. We'll call that good. Okay, and we've got our hole for drilling all set. The next piece is the sail. Now the sail can be turned like I've done here, or it can be just cut on the bandsaw. The sail is kind of the real artistic expression point. You can make it anything you want. You can pierce it. You can dye it. You can cut intricate shapes, logos, whatever you want, as long as it's something relatively lightweight and large enough that it's going to catch the wind. So for that, we're going to do a piece of maple. So there's our bottom set, just a little kind of, you know, crazy angle. But this can be anything you want. This was kind of a tough one because I wanted the cable to be minimally in the way. So I came up with that little hole in there and crimped the cable through there, and I think it worked out pretty good. All right, now the last piece that you'll need to turn, there's really not a lot of turning involved. You're going to take your drill chuck and you're going to mount it in the lathe, in the headstock. And we're going to use dowel rod. So what we're making is I should have been using this all along. These support pins. So I like when the rods are sticking out just a little bit on each side. I think it kind of has a nice feel to it. I mean, it's going to be very difficult to hide it, so why not show it off? So if we have it out 1/8 of an inch on each side, so we need 1.5 inches. Right? Yeah, 1.5 inches. We're going to mark the center of our pin, 3/4. All right, we're going to make 3 cuts on this. We're going to chamfer each edge, and we're going to make a V cut right in the middle. That V cut is where the string sets so that the chime tube stays centered when they're hanging. For that, I've got an old, might be a Craftsman, spear point steel tool, but it works really well for it. So just a little chamfer. A V right in the middle, flip it around, again, flip it around. And notice I'm just tightening the chuck by hand. Maybe a very little sanding, there'll be a little burr on that. There we go. So there's your little dumbbell. Okay? So that completes all the turning. Now, the critical part is tuning of the chime tubes. I'm going to demonstrate this on a metal tube because it'll be easier to hear, but I'll also show how we do it on the wooden tube. It's important to understand why wind chimes make noise. Just like any musical instrument, you've got vibrations that are occurring. If you think of a chime tube like a guitar string, when a guitar string gets plucked, you can actually see it vibrating. You can't really see it on the chime tube, but the same thing is happening. The vibrations are creating a resonance through the length of the musical instrument, and that's moving the air molecules which actually make the noise. Science, blah, blah, blah. Okay, so our chime tubes, when we strike it, it creates that vibration. So if we kind of look at, there's down through the center, and our vibrations are kind of doing this motion. So what we're trying to achieve is we want to hang the tube from the exact spot where this wave crosses over the center line of the tube. So right here, and then you're beyond center, so somewhere up in the top third. There is a mathematical formula for this to get you kind of close, and that is 22.4% of the length of the tube from the top. Something like that. Now, how can we do it easier? Okay. So you're going to take your bell and you're going to set your pipe on your workbench. This is just a standard 2-foot length from Home Depot. They work really well. So you can see. You're going to grip it at the top with 2 fingers, just enough to be able to pick it up. You don't want to grip it because that dampens the vibration. And you're going to start, and in 1/2-inch increments, you're going to move down, and you can hear that noise getting a little bit longer and cleaner. Now it's starting to get less. We might be able to find the second one. Now. Okay, so right about there, and we're going to mark it approximately where my fingers. So that is rough tuned. So I'll show you the same thing, same exact procedures. So it's kind of just flat. There's not a lot of difference on wooden wind chimes. That's why I did the metal first. The wooden wind chimes are more of a clunk and a clunk. So it's much more difficult. It's a much more natural sound. I think that's why I like the wooden ones better. But clunk. You have to kind of squeeze when you do that. On the subject of metal chimes, you can make this even better if you want. So we need to lessen the dampening effect that our fingers have. So we're going to take a piece of string, we're going to choke it right on our line. You're going to hang it. You're going to do the same thing, but this time moving just in 1/8-inch increments. So we find that sweet spot above and below where your rough tuning was. That's good. So once we found that, then we mark our new line and we put a circle around it so we know for sure. And that's where we will drill our hole. Now, not all metal tubes work good for wind chimes. So this is galvanized fence post. More like a dinner belt kind of sound. I believe that is because this is welded seam tubing. So it starts out flat, goes through a machine, and slowly becomes round, and they weld that seam. As opposed to extruded tubing, which is 100%, there's no seams or anything like that. So that weld that's in there, I think, helps to dampen that vibration somewhat. So it was an experiment, but they can't all be gems, right? Okay, so now that we've got our location for our wooden wind chime, we can go ahead and drill this hole. To do that, you can just put it on the drill press and drill it, but you're going to get tear out on the bottom side of your hole. I learned doing those. So simple jig, you're going to, this is just scrap 2x4, rip both sides to square them up, find the exact center, drill with a Forstner bit this time, this whatever size tube you have, and then you've got 2 even supports for your drill press. And that's 1/4-inch dowel, so 1/4-inch brad point bit. Now I'm just eyeballing this. First off, you should make sure that I'm high enough. So there's that. We get our little dowel that we made. So there is the finished chime tube with the post. Once you have chimed everything, you've got your finish applied and you're ready to string these up. Stringing a set of wind chimes is an extremely tedious and frustrating project. So I did this one maybe 2 weeks ago, and I'm really not happy with how it's strung up. You want, obviously, the tops to be all even, but in the interest of a demonstration, I wanted to show you guys what not to do. So, and I didn't have time to restring it, so. So overall, it's pretty good. What I tried to do was I tried to connect alternating tubes. So it's one line going up and over into the other tube. When you're making loops, it's really tough to get it exact. I think if I was, even a quarter of an inch closer, it might be kind of acceptable. But so I've come up with a better method, I think, for doing this, and I will supply that to Chuck to put on the website, so that'll all be there. I'm not going to show you how to string them because it's take me 2 hours probably. But that's basically wind chimes in tuning your chime tubes. Okay, so these are all exactly the same, so they all play basically the same note or the same sound. You can't. There's another way. The professional wind chime makers tune they have instrumentation and oscilloscopes and stuff like that. But the rough tuning and even the fine tuning can still be done by ear. You can tune them the way I've shown you by locating the hanging pin in a specific spot to achieve your note. Or you can pick a different spot and you can vary the length of the tube. Most commercially available wind chimes are usually, you've got the longest one and then they step down in 2-inch increments from there. And that achieves, usually, and I'm not a musical guy, but a 5-chord note. So each of the 5 tubes will produce a specific different note. You can actually even get custom wind chimes made to a specific chord, say from your song with your wife or your spouse. So there's a lot of different things that you can do. If you do some searching online, you can find charts and diagrams on how to achieve an A or a B note or a D flat or whatever. So there's a lot of information out there. I've got a couple websites that I'll also supply to Chuck to put on the newsletter or on the website with lots of information. There's a guy out there who is, I believe, literally a rocket scientist engineer that is obsessed with wind chimes. And he has gone to extraordinary levels to achieve perfect tone on his wind chimes. And I'm kind of like, why? Most people aren't going to be able to really tell the difference. So, yeah, you need to, whenever you're tuning, you're always tuning with your finished tube. It's the last thing that you do. So, yeah, whatever length your tube is. So even if I was to cut this down to 12-inch, we could still tune that in. Even 6 inches, you could probably get a really good sound out of it. I just did depth. I do depth spray lacquer on everything. It works really well on the bloodwood. I think because bloodwood is kind of oily and sealed already, but the depth spray lacquer reacts really well with it. You want it to be, again, I don't think there's any set rules. You want it to be long enough that the wind is going to allow it to allow the action to happen. It needs to be able to swing. If you make it, real short, it's not going to catch the wind as well. The longer the string is to your sail, the lighter the breeze is needed in order to move it. So if you like wind chimes but you don't want to hear them a lot, there's a couple things you can do. You can shorten up your sail so it doesn't catch wind as easy. You can make the bell smaller so that it takes more wind to move it into the chime tubes, or make it closer to the chime tubes so it goes off more often. So there's some charts that I found, but they're so varying. It basically is centered between the hanging method and the bottom of the tubes. But if your tubes are all different lengths, you got to kind of go with the average. I just eyeballed it. Okay, so as I'm not a spindle turner, I'm not a music person, I'm also not a fisherman. This is 50-pound test line. 50-pound test line, and I looked up a whole bunch of knots, and I knew that I was going to run into a problem with tying knots and getting exact length. So I chose to go with jewelry crimp beads. And I think it worked really well. I just need to kind of adjust the top a little bit more. So the test line, this is 150 yards, 50 pound. I think it was like $2.75 from Walmart, everybody's favorite. The crimp beads, also from Walmart in the arts and crafts jewelry section. You get 144 of them, crimp tubes, sorry, 144 of them, I think, for $2.50. And they're these little metal tubes. I'm not going to pass them around, but you guys feel free to look at these. No, it does not come with a tool, but if you're going to go with this method, I would recommend this tool, again at Walmart, $10. It's a double crimping set of pliers. So it takes that round crimp tube and it crushes it down kind of like this, and then you move it to the other jaw, and then it folds it over on itself. So it's like a double crimp that's never going to come apart. Okay, so I don't necessarily recommend that you put these outside. As you can see, it's very lightweight. I think that it would hold up for a couple years, but it is wood. So if you're going to put it outside, I would recommend in a porch or something like that. I would recommend inside your house by the windows. So it's still going to work, but it'll be inside. Or in front of your wife, yeah. If you're going to put it outside, I would recommend some sort of like a marine varnish, spar varnish, something like that, and I think it would hold up very well. But again, it is wood, so it's not going to last forever outside. I don't know that on the wooden tubes, I didn't notice any difference before and after finishing, and those have about 6 coats of lacquer on them. So it sounded the same to me. But again, you're dealing with what was it I said, a donk versus a donk? Yes. So my drive cone, I tried to match, I believe it's 60 degrees, but for doing what this is as a drive cone, it could be any angle, as long as it's smooth and fits. And for thinning down the tubes, an 1/8 inch wall is still pretty good, and you notice I was probably right at the borderline of starting to get some vibration while turning, but I haven't noticed that yet. So maybe I don't even think, if you went with hard maple or even something like that, I don't think it would really matter. With an 1/8 of an inch wall, if you went thinner, it might. I'd be curious to see, I'm not going to buy it, but an ebony spindle, I bet that would really sound good. So it's not that far from the end. So what I do is I start the pin about halfway through, and then I just drop the fishing line down, and you can just eyeball it in place. And then once you've got it looped over the pin, just push the pin all the way through. Real scientific. Thank you, guys.